Hey everyone. Well, we're about to start a new unit today. This is exponential and logarithmic functions. Now you've heard of exponents before. We've dealt with those in previous math courses, but we're going to tie them into something called logarithms now, which is really, well, hate to give it away, but it's just the inverse of exponential functions. So being able to do your exponent laws, which is this first lesson, is very critical to the rest of this unit. So let's make sure we're up to speed on our exponent laws. Okay, so let's review something. I think this was from last year or the year before. Our exponent laws, basically, let's talk about the terminology first of all. So when I talk about a power, I am not talking about this, okay? That is not the power. The entire thing, x to the exponent n, is the power, okay? And the base of that power is called, well, in this case, the base is x, okay? And the exponent is the exponent, obviously. Okay, so just a bit of terminology there. Let's run through our, review our exponent laws. Okay, we have product law, x to the m times x to the n. So the rule is when you're multiplying two powers, right, this is multiply, and the bases are the same, both base x, you can add the exponents. Okay, that's the rule. You don't change the base, it doesn't become x squared or anything, or 2x, it just stays as x, but you add the exponents. And with quotient, so if you're dividing two powers and the bases are the same, both x, you would subtract the exponents. Okay, also power of a power. So if you have an exponent outside of a power like that, then the rule is that you multiply those two exponents. So m times n, or write them next to each other, mn. Okay, power of a product. Okay, if you have two things being multiplied within the brackets, that exponent can be distributed to each thing inside. So it becomes x to the m and y to the m. Okay, same rule with the quotient. If you have x over y to the m, that can become x to the m over y to the m. The only time this doesn't work is if you had x plus or minus y to the m. We all know that that does not equal x to the m plus y to the m. Okay, and you're probably saying, why do I know that? Okay, let me give you an example. Let's say we had x plus 2 squared. Okay, how do we expand that? We would go x plus 2 times x plus 2, and then we would expand that, right? Distributive law, or FOIL it out, right? And we get x squared plus 4x plus 4. That is not the same as squaring each thing individually and writing that as x squared plus 2 squared, x squared plus 4. See that? Some of the terms are the same, but we're missing that term, right? So please, if you're adding or subtracting within the brackets, do not apply the exponent to each one, only if you're multiplying or dividing. Okay, so the other rule, integral exponent rule, if you have a negative exponent, that can be written as 1 over x to the positive m. Another one I want to throw at you with that, let's say we have a fraction like x over y to the negative m. I can reciprocal the fraction so that it becomes y over x, and then that exponent would go positive, so to the positive m. Okay, so basically, yeah, we're going to practice that more later. All right, rational exponents, x to the m over n. Okay, so if you have a fraction, which is what rational essentially means, in your exponent, we can write that, this is weird, but you've done it before, x to the, and it's going to be a radical. So now the question is, which number goes where? Does the n go as the root or on the exponent on the x? So the n goes here and the m goes on the x, or we can write the m completely outside of the whole thing like that. How do you remember that? Well, I have a silly little saying in which to remember it. Okay, just ask yourself where, so whatever number is in the index, this is called the index here, the index indicates what root it is, right? So this would be the nth root, okay? So just ask yourself where, this is silly, I know, is the root on a plant, okay? I know, has nothing to do with this, right? So where's the root on a plant? Well, it's at the bottom, of course, right? So where is the root number when you go to write it as a fraction exponent? It's at the bottom. Okay, so it might work for you if it might help you remember that. Okay, let's take a look at the first example here. Write each expression without brackets and with positive exponents. Okay, so let's look at the first one here. No brackets, so nothing to do there. We're not multiplying by anything. Well, 1/2 times y to the negative 6, but so we just don't want to have negative or a negative exponent here, really, as we're already at that step. So let's think of this as 1/2, and then that y to the negative 6 could be written as 1 over y to the 6. And then, remember, if we're multiplying fractions, you multiply the numerators, 1 times 1, multiply the denominators, 2 times y to the 6, and there we go. Okay, so that worked quite well. Let's try b here. Okay, so now you'll notice, so we can't divide x to the negative 3 and y to the negative 2 because the bases are not the same, right? One's x, one's y. Okay, so we can't divide, but we could write this with positive exponents. Now, you know how this y to the negative 6, which was sort of like on top, if you want to say, in the numerator, we moved it to the denominator and the exponent went positive, right? We could do that with this, okay, not the 5. The 5 doesn't have an exponent on it, so 5 stays on top. We could move that x to the negative 3 to the bottom and the exponent would go positive, okay? And alternatively, the y, if we moved it to the top, would also change to a positive exponent, okay? And that would be your final answer. Again, don't move the 5. The exponent on the 5 right now is a positive 1, okay? It does not have an exponent of negative 3 on it. All right, good. We're going to do more of these, so let's try the next one. Okay, we have multiplying going on here. Okay, so we're going to multiply things that can actually be multiplied together. So the 4 and the 2 could be multiplied together to give us 8. Okay, x cubed could be joined with the x to the negative 4 because they have the same base, right? So we're multiplying, so we would add the exponents, so it'd be 3 plus negative 4, which would be negative 1. Okay, if you have trouble adding integers, think of it this way. I sort of do it like a football team. If I have positive 3 and then a negative 4, I think of it this way. I have 3 people from the positive team on one side of the football field, 4 people from the negative team. These guys are going to line up and take each other out, and we're left with 1 negative. That's how I do those ones. So if that works for you, you can use that. All right, now with y's. Oh, what's the exponent on this y? If nothing is written, assume it to be a 1, and then we're multiplying the y's, so we add the exponents, 1 plus 2, and that'll be y to the 3. Almost done, but we don't want negative exponents, so this x to the negative 1 could move to the bottom. These are all multiplied together, so we're okay to do that. If we're adding anywhere, we couldn't do it, but that would go down there as x to the 1. And you don't have to write the 1 on the x if you didn't want to. All right, so why don't you guys try D, pause your video, and then we'll check back and see if we get the same answer. We've got dividing going on the next one. All right, pause your video, please. Okay, how do we do? Did you guys get negative 6m q to the 6 over p to the 5? If so, awesome. Okay, so we divide the numbers. We get negative 6. Divide the m's, so subtract the exponents. 5 minus 4 is 1. P, divide those, so subtract the exponents, negative 3 minus 2. I usually suggest writing these off to the side when you're trying to figure them out, just so that you don't mess up on them. It's easier to see them if they're written off to the side. And then finally Q, 4 minus negative 2 would be 4 plus 2, so that's why that's a 6. Hopefully you guys didn't move the negative 6 to the denominator. You only do that if it's a negative exponent. A negative 6 does not mean negative exponent. It would have to be 6 to the negative 1 or something. Okay, good. Let's try the next one. Now, next one we're using the power of a power rule. So, and we have everything being multiplied together inside this bracket. So that means this power can be distributed to each thing inside. But what people forget is the 3 is its own factor. So let's put a little 1 on that 3, just to remind us that it's 3 to the 1, x to the 2, y to the 3. Okay, so let's multiply. Power of a power, you multiply. So 3 to the 1 times 3, 3. X to the 2 times 3, which would be 6. And y to the 3 times 3, which is 9. Okay, so 3 cubed is 27. That's 3 times 3 times 3. And then we have x to the 6, y to the 9. No negative exponents, so that one's good to go. Okay, let's try F. I want you guys to try F, and then we'll check in and see if we got the same answer. So pause your video, please. Okay, so we divide the numbers again. 12 divided by 3 is 4. Divide our powers. The exponent on the b on the bottom is just a 1, so we write that. And we are dividing, so we subtract the exponent. So I wrote this off to the side, especially with fractions. Negative 1/2 minus 1, need a common denominator, so 1 becomes 2 over 2. Then we can subtract the numerators. Negative 1 minus 2 is negative 3. And there we go. So we have 4b to the negative 3/2. Then we have a negative exponent on our b, so we can move that factor to the denominator. All right, good job, you guys. Let's take a look at the next page. Okay, example 2. Simplify the following. Write the answers with positive exponents. Okay, so we've got power of a power happening again. So let's put an exponent of 1 on the 4 and also the x, because that doesn't have an exponent either right now. All right, distribute that in. 4 to the negative 3, x to the negative 3, we multiply the exponents, and y to the negative 2 times negative 3, so positive 6. All right, do not try to get a number for 4 to the negative 3 yet. Just simply deal with the fact that we have negative exponents now, because there's not much else we can do. So both of these factors, because they have negative exponents, will go to the denominator, and y to the 6 will be left on top. And you can do that because everything is multiplied together. If it wasn't, if they were adding and subtracting, no, you could not move things to the top and bottom. Okay, so we'd have 4 cubed, and then x cubed, and then final step, you would just want to figure out what 4 cubed is. Now, it's very handy in this unit. I'm not really suggesting you necessarily memorize them, but it sure comes in handy if you know them really well. So if you know 4 cubed is 64, you don't have to slow down and go to the calculator to figure that out. So I would suggest, like, numbers less than 10 if you know a few of the powers. That would be a good idea. All right, part B here. Okay, this one's a little different. Notice we've got the fraction here. And remember the one example I gave you where it was x over y to the negative m, and I reciprocaled the x over y to y over x, and then that became positive m. Same idea. I would probably do that here, or should I? Yeah, let's do it. Okay, there's another way you could do it. You could just distribute it in and we'd be good to go. So we are going to reciprocal that. Although if we multiply that in, okay, I've changed my mind. It might just as be easy to distribute that in. So on to the 3, the 4, the x cubed, the y to the negative 2. So we'd have 3 to the negative 2, x to the negative 6, and then 4 to the negative 2, and y to the positive 4. Okay, so now we are going to fiddle with things and make sure we have positive exponents. The only factor here with a positive exponent right now is y to the 4, so that is going to stay where it is. Okay, we'll put it there. Everything else changes location. So 3 squared goes to the bottom, x to the 6 goes to the bottom. Okay, and then on top, 4 to the negative 2 goes up, so it's now 4 to the positive 2. All right, we just need to simplify the numbers. So 4 squared is 16, 3 squared is 9, x to the 6, y to the 4. And there we go, that would be our final answer. Okay, sometimes this reciprocating the fraction is a good idea, but on this one we are okay to do without. Okay, example 3, very good idea to know how to do these, especially if you're planning on going into calculus where you need to be able to do some things in your head without the calculator. So 2 to the negative 3, so let's use our negative exponent rule. That could become 1 over 2 to the positive 3. And 2 to the 3 is the same as 2 times 2 times 2, so that's going to become 1 over 8. Okay, excellent. Okay, 81 to the 3/4. Well, we've got a fraction in the exponent. Fraction, think radical. So 81 under the radical sign. Which is the index of the root? Where's the root on a plant? The bottom. So 4 there. Now, the 3, we could put it inside on the 81 or outside the whole thing. I would put it outside because it's a lot easier to find the 4th root of 81 rather than the 4th root of 81 cubed. Okay, so the 4th root of 81. What number to the 4th gives you 81? Okay, again, something you should know or work on is that number would be 3. 3 to the 4th is equal to 81. Now that outside 3 is still there, so 3 cubed is going to equal 27. All right, good. Forgot to mention this one, but this one's important. Anything to the 0 exponent is equal to 1. Okay, so remember that one. You guys try D, and then in part 2, we'll check and see if we got the same answer. Okay, so please go to part 2 now and work on D before you go. All right, we'll see you guys there.